Hi, I'm Edward, and I'm going to show you some magic with these cards. It's called column size sorting. Are you surprised? Good.
Explosion.
Okay, so I have here some cards, and we're only going to use about 7 of them. And the top 7 cards I have are the Ace, 2, 3, 4, 5, 6, and 7. And so you can consider these cards sorted for now, and this is basically what we're going to use for a simulated array of integers or just numbers in general. We have 1, 2, 3, 4, 5, 6, 7, ace being 1, 7 the highest, ace the lowest. So therefore we can consider this array sorted. But in order to talk about arrays and sorting them, we have to at least first make the array not sorted, which is no order at all. So I'm just going to shuffle them, blah, blah, blah. And yes, I have 7, ace, 5, 3, 2, and a 6. Now, obviously, this isn't in increasing order, so we don't consider it ordered for now. And the first type of sorting that I'm going to cover is selection sort. And what this does is that it goes through the array, or at least our cards here, the amount of cards minus 1 times. So it would go through these cards 6 times. And what it does is it has a variable, and we'll call it smallest. And so we set it to the very first card or element of the array that we have. So right now, smallest equals 7. And we move on to the next position and see if that element is greater or smaller than our smallest variable. And because ace is 1 and 1 is smaller than 7, we then set the smallest variable to the ace. So now smallest equals ace. And then we move on to the next position, and we do the same exact thing. We compare them. Ace is still smaller than 5, so smallest still equals ace, or 1. We move on to the 3, and yeah, ace is the smallest so far, smaller than a 2, the 4, and a 6. So what we do is we take this element, and we take the very first element that we had, which is here, the 7, and we swap them. So now that we have the smallest element in the very front. And so we can just ignore that for now, and we look at these elements as we, in selection sort, we cut division of that just by getting rid of the very first element. And we move on, and again, we set our smallest variable to the very first element of what we're covering, which is the 7. So smallest currently equals 7, and we move on to the next element, next position. 5 is smaller than a 7, so we set smallest to 5. We move on to the next position. Smallest then equals 3 because 3 is smaller than 5. We move on, we set it to 2 because 2 is smallest than 3. And we move on to smallest still equals 2 because it's smaller than 4 and 6. So by that logic, 2 does have to be the smallest variable, or sorry, element in this array. And we take the first element of what we're covering so far, which is the 7, and we take that 2 and we swap them. So now what we have is that the 2 smallest elements in increasing order so far are in the very front, and we forget about them for now, and we focus on these 5. So we do the same exact thing 4 more times. So smallest equals 5, we check with the next element, and we set it to 3 because 3 is smaller than 5. Move on. Smallest still equals 3 because 7 is bigger. Move on. Still equals 3 because 4 is bigger and 6 is bigger. So therefore, we take the 3, we take the 5, and we swap them. And see now, ace, 2, 3, increasing order. So far, it's good. We set smallest to 5, we check the 7. Obviously, 7 is bigger, so smallest still equals 5. But we set it to 4 because 4 is smaller than 5. And 6 is not smaller than 4, so we take the 4 and the 5, and you switch them. Ace, 2, 3, 4. Okay, 2 more steps to go. Smallest equals 7. We set it to 5 because it's smaller, and it's still 5 when we compare it to the 6, so we take the 5 and the 7 and we swap them. And then we just compared these two because there are only two elements left, and obviously 6 does have to come first. So therefore, from that selection sort method, we now have a sorted array of elements, a sorted 7 cards in increasing order from ace to 7. That is the first kind of sort.